guys, welcome back to a new academic learning video, and in this video I'm going to be teaching you how to multiply and factor quadratic equations. Alright, so let's get started. So you may have heard of the distributive property before, and basically what this means is if you have some number a times b plus c, and that's going to be equal to a times b plus a times c. And basically, why this is called the distributive property is you can think of the a as distributing over the a and c. And you can think of the a distributing, meaning multiplying. Alright, now you may be wondering why this is true, and I'm not going to get into the proof in this video, but I will have a proof linked in the description if you do want to know, but it is an advanced proof, which is why I'm not showing it in this video. Alright, now let's get into a more advanced version of the distributive property called factoring. Now factoring is basically, it's not really more advanced, but it's basically just the opposite of the distributive property. So instead, we can take AB plus AC. So we're starting at the opposite spectrum, and instead of multiplying, now we divide. So this is, or not really divide, but we're basically just taking out this common factor of a. So if we have this and we have a common factor of a, then we can take it out to make this equal to a times b plus c. Now you may be wondering, well, why can we take it out? Well, it's not really something that's mathematically proven, but one thing you can think of is that this, if we distribute this right here, we get this expression right here. So that's why it's true. Alright, now these are very useful facts, so have them in the back in your head while we go through the rest of this video. Alright, now let's do the distributive property, but slightly modified. Instead of like a times b plus c, let's do something like a plus b times c plus d, or a plus b times c plus d. Well, one way you can view this is that we can simplify this a bit by letting y equal c plus d. And this is just a change of variables to simplify this. This is a useful trick you'll see in a lot of math. So times y, and now we can distribute now, and if you don't see why we can distribute, hopefully if we write it in this way, now you may be able to see how we can distribute. So this is y times a plus y times b. Okay, but what is y? Y is just c plus d. So we can simplify this further by writing this is c plus d times a plus c plus d times b. So let's go over this 1 second. So if we have, or actually let me rewrite this one more time, it's a times c plus, or a times c plus d, and we just changed the order here, so not anything really special. Alright, now let's review what this means. So our original expression, and remember, we didn't change our original expression at all. This is still our original expression. We just did some clever tricks by changing variables and distributing. So if we have a slightly modified distributive property like this, then what we can think of is this is the first term in this, which is a, and times, or distributive of the second expression, which is this right here. And then we can think of the second term right here, distributive the second expression, which is this term right here. So that's how I like to think of it, is you take this, the first term, and distribute it over the first term in the first part, and then distribute it over the second part, and then take the second term in the first part, and then distribute it over the second part. But you don't have to think of it like that. I'm just telling you how I think of it. Alright, now you may be wondering why this is useful. Well, or like, what does this have anything to do with quadratics? Well, we are getting there. And to get there, we have to do one more thing. Instead of writing just random variables, let's write polynomials that we're multiplying together. So x plus 1 times x plus 2, let's say. Now, let's see. Well, we know that we can just take the first term in this, which is just x, and then distribute it over the entire second expression. So this is x times x plus 2, and do the same thing for 1. So that's the second term times the expression again, the second expression. Now we can distribute again, so x distribute over x plus 2, so that's x times x, which is x squared, but I'll just write it as x times x for now, and then times plus 2x. Now for the second one, this is 1 times x plus 1 times 2. Okay, and now we can write this as x times x is x squared, and 2x is 2x, but we're gonna add a 1 times x, so it's 3x. So we're adding 2x, and then this is also gonna be x. And then for the constant term, we just have 2. So what we're saying is that this multiplication turns into this polynomial. Okay, so now you may be seeing kind of what this has to do with quadratics, but let's go ahead one step further. All right, so let's learn how to factor, not just regular factoring like I showed you in the beginning of the video, but actual factoring of quadratics. So to factor a quadratic, let's just start off with a very simple example, like x squared plus x. First of all, why would you want to factor a quadratic anyways? Well, one thing you may be thinking is, how do you solve for x in quadratic scenarios? Like, if this is a quadratic equation, how do we solve for x? Well, what you've been taught is to isolate the variable on one side and then solve for x. But how can we isolate the variable on one side here if there's 2 copies of the variable? Well, one thing that you can do is do a completely separate method, and by factoring. So here we can write this as x squared is just x times x, and then x is just x. And then you may recognize from before, or maybe this becomes a little bit more clear if we write this x as 1 times x. And now you may recognize from before, in the beginning of the video, that we can factor out one of the common product in both of these, called the common factor. So this is x times x plus 1. So basically what we did is that we rewrote this original expression into this expression right here, just from the rules we stated at the beginning of the video. And now we can use a trick called the zero product property to help solve for x. So the zero product property, it's actually kind of intuitive. So basically what it says is that if we have 2 products, A and B, and we multiply them together and they equal 0, well, if 2 things multiplied together equal 0, then either one is 0 or the other is 0. Because if either one of them is 0, then the entire thing is 0. So either A is 0 or B is 0. It doesn't need to be both of them, because let's say A is 7 and B is 0, then that still multiplies to 0. So both of them don't need to be 0, but at least one of them needs to be 0. Okay, so now we can use this in this expression. So if we have 2 products, then we can write this as either x is 0 or x plus 1 is 0. And if x plus 1 is 0, then that means x equals -1. And this is actually the solution to this equation above. Now that may be a little counterintuitive at first, because when you're solving for x, normally you have one solution. But for higher order polynomials, you actually have multiple solutions. In fact, if you have a polynomial of degree n, and degree just means the highest order term. So let's say we have x cubed plus x, not to the fourth, but x squared plus 3x plus 2. Then this is going to have 3 solutions. And the highest term, n, then that means it's going to have n solutions, n different solutions. And now, they may not always be real number solutions like we have in this scenario. So that's not really the topic of our video though, so let's just get back to this quadratic. So we have a degree of 2. That means we have 2 solutions right here. So 2 solutions. And you can test out these solutions. 0 squared plus 0, that's 0. And negative 1 squared plus negative 1. Well, negative 1 squared, that's just 1. And then plus negative 1. 1 plus negative 1 is 0. So basically, let's just review how we solved for x. So we took a quadratic, and then we reduced it down to products, and that step is called factoring. And then we can use the zero product property to solve for x. All right, so let's do a bit of a more advanced way to solve for x. And that's if we have something like x squared plus 3x minus 4. Credits to math, and math is fun for this problem. But basically, for this, we can use the same logic as before. We need to reduce it down to its factors. But how can we reduce it down to its factors? We can't, like before we wrote x squared as x times x, and then 3x as 3x minus 4. But still from here, it doesn't look like we can factor out a common term or anything. But what we can do is factor out x plus some number times x plus another number. And let me show you how you can do that. And now, to show you how you can do that, I'm actually going to start from the factored form instead of starting from the quadratic. And you may see why that is true in a minute. So if we have a factored form, then let's write it as a quadratic. And then from there, we can use a quadratic and write it from a factored form. If that sounds a bit confusing at first, don't worry, because I will explain. And then if it's still confusing, you can leave that as a comment in the comment section. All right, so basically what I did for this first step is the same distributive property thing that I've told before. We're taking this first term and multiplying it by the whole second product, and second term multiplied by the second product as well. So we can rewrite this again as x squared plus bx, just from the distributive property, and same thing for this, ax plus ab. Now from here, you may not notice this at first, but we can actually group these two things together by factoring. We can factor out the x to get x times b plus a plus ab. Now I'm actually going to write the b plus a at the beginning because it's a bit more convenient. Okay, now basically what this is saying is that if we have this quadratic right here, then we can write that as a factored form. So let's go back to what we learned, or what our previous problem is. X squared plus 3x minus 4. And now we want to write this as a factored form, or equals 0. And so we want to write it as a factored form. So we can actually use this. So basically what this is saying is that our coefficient here, the number in front of x, that number is b plus a. So b plus a is 3. And then our constant, minus 4, that's a times b from this right here. Okay, now this may be confusing, but just hang with me here and I'll explain it a bit later because it'll be less confusing then. So if we have two numbers and they multiply to 4 and two numbers that add to 3, well, you might just be able to do a bit of trial and error to find out the solution, but maybe one solution, let's see, two numbers that multiply to minus 4, that could be 4 and minus 1. So if a is 4 and b is minus 1, and that satisfies these two equations here, and you can check that on your own. But basically, what we're doing here is we're working backwards from this, and this is what I mean by working backwards. We take our quadratic, and now that we know a and b, we can use it to write it in factored form. We can use this to write it in factored form, and this is just x plus a times x plus b. So x plus 4 times x minus 1 equals 0. Okay, one more quick review for what we did here. So we took this factored form, and then we made a quadratic out of it. So now, if we have a quadratic, we just need to find out these a and b's, and we can write it in factored form. So let's go ahead and solve for x here. So either x plus 4 equals 0, or x minus 1 equals 0, x minus 1 equals 0. And I encourage you to finish off the rest of the problem and test it in our original solution, or original problem, and see if it works. Anyway, that's going to be it for this video. Thank you for watching, and I will see you in the next video.